In this section, we will talk about solving multi-step equations. First, let's look at the steps to solving multi-step equations. Step 1, use the multiplication principle to clear any fractions. We will talk more about this later. Number 2, use a distributive property to remove any parentheses. Number 3, combine like terms on each side of the equation. Number 4, use the addition property to get variables on one side of the equation and constants on the other side. It doesn't matter which side we put the variables on and constants on as long as they're on opposite sides. And lastly, multiply or divide to solve for the variable using the multiplication principle. Let's look at some examples. Example 1. Let's solve negative 9x plus 3 equals to 27. Let's go through each step. Step 1. Use the multiplication principle to clear any fractions. We don't have any fractions, so we're going to skip that step. Step 2. Use a distributive property to remove any parentheses. We don't have any parentheses, so there's nothing to distribute. Step 3. Combine like terms on each side of the equation. On the left side of the equation, we have negative 9x plus 3. On the right side, we have 27, so there's nothing to combine since we have no like terms on either side of the equation. Now, step 4, use the addition property to get variables on one side and constants on the other side. Since the variables are on the left side, let's move the constants to the right side. So we would have negative 9x equals to 27 minus 3, which is 24. Multiply or divide to solve for the variable using the multiplication principle. Since the x is being multiplied by negative 9, its inverse is to divide by negative 9. So our answer is x equals to, when you have a positive divided by negative, simply move the negative to the middle. You have negative 24 over 9. Now, every fraction needs to be in reduced form. So to reduce, we would divide both the numerator and denominator by 3, and that will give us negative 8 over 3 as our answer. Let's look at another example. This time, let's solve 25 equals to negative 3 plus 4 over 7b. First step, use the multiplication principle to clear any fractions. Now, this is a pretty simple equation, so we don't have to clear the fraction. And in fact, I'm going to skip that step. Step 2, use the distributive property to remove any parentheses. We don't have any parentheses, so there's nothing to distribute. Step 3, combine like terms. We have no like terms on either side of the equation. Step 4, use the addition property to get variables on one side and constants on the other side. Now, all the variables are already on the right side of the equation, so we can add 3 to each side in order to isolate the variables on the right side and the constants on the left side. Now, we learned previously that if a variable is multiplied by a fraction, to undo that, you would multiply by the reciprocal of that fraction, which in this case is going to be 7 over 4, and multiply the left side also by 7 over 4. So the 4's cross cancel, the 7's cross cancel. On the right side, all we have left is b. On the left side, 4 goes into 28 7 times, and 7 times 7 is 49. So our solution is going to be b equals to 49. Let's look at another example. Step 1, clear any fractions. We have no fractions. Step 2, use a distributive property. We don't have any distribution. Step 3, now we can combine like terms. On the left side of the equation, we have a positive 4x and a positive 3x. We can write that as 7x minus 7 on the left side. On the right side, we do have like terms as well. We have a 10 and 8, so we can rewrite this as 2x plus 18. Okay, next step. After we combine like terms, use the addition property to get variables on one side of the equation and constants on the other side. So let's subtract 2x from each side. That will bring the variables to the left side. We get 5x minus 7 equals to 18. Now let's add 7 to each side. This will give us 5x equals to 25. Since the x is being multiplied by 5, we would divide both sides by 5. And our solution is going to be x equals to 5. Here's another example. Step 1, we have no fractions. Now step 2, we do have distribution. So let's distribute the negative 6 to the x and negative 6 to the negative 4. Negative 6 times x is negative 6x. Negative 6 times negative 4 is positive 24. Then we have plus 3 equals to negative 8x plus 7. Let's combine our like terms. 24 plus 3 is 27. So on the left side, we will rewrite this expression as negative 6x plus 27. On the right side, we have no like terms, so that will be negative 8x plus 7. Now, use the addition property to get the variables on one side. It doesn't matter which side we bring the variables on. So I'm going to add 8x and bring the variables to the left side. This will give me 2x plus 27 equals to 7. Now I will subtract 27 to get the constants on the other side. So I will get 2x equals to negative 20. Since the x is being multiplied by 2, the inverse is to divide by 2, and we would get x equals to negative 20 over 2, which is negative 10. Next example, 9 times the quantity 2x minus 3 minus 8x equals to 8 minus 4 times the quantity x minus 3. First, we don't to look for any fractions to clear, we have none. So now let's distribute the 9. 9 times 2x is 18x. 9 times negative 3 is negative 27. We also have distribution on the right side of the equation. Negative 4 times x is negative 4x. Negative 4 times negative 3 is positive 12. So we distributed the 9. We distributed the negative 4 to remove any parentheses. Then we would combine our like terms. On the left side of the equation, we have 18x minus 8x, which is 10x minus 27. On the right side of the equation, we have a negative 4x. 8 plus 12 is 20. Now let's get all the variables on one side, so we can add 4x to each side. This will give us 14x minus 27 equals to 20. We would now move the constants to the right, so we would add 27 to each side. We would get 14x equals to 47. And lastly, we would divide each side by 14, so x equals to 47 over 14. Now this cannot be reduced because no number can divide both 47 and 14 at the same time.